All right, so this is going to be the solutions to homework 5-7 for AP Calculus. All right, so in this first problem, I just want us to figure out what the area is for this line. So first of all, what is the area looking like? So if I'm always going to make a line to the x-axis. Always make a line to the x-axis. So, and then you can just do lines to shade them in. So that's the area that I'm looking for. This is a 1, 2 by 1, 2, so it has an area of 4. And then I need to come down here and I say, okay, what is the function that I'm actually taking the integral of? So I'm taking the integral from 2 to 4, so I can say from 2 to 4, and the function is, it's a constant function of just 2. 2, and then don't forget your dx, 2 dx. And then solving this thing analytically, this is going to become 2x evaluated between 2 and 4. That's going to turn into, subbing in 4, 2 times 4 is 8, minus subbing in 2, 2 times 2 is 4, and that's going to be 4. Perfect. So we're just making sure that this number matches this number. Let's move on to the next problem. Slightly different, there's an open hole here. Does that change anything? Not really, because the number of points in here is infinite. This is one of the infinite, which is basically nothing. It doesn't affect it. So again, always draw lines to the x-axis. All right, and this is the area that I'm trying to find. I shaded in. And now I need to find the area, so it's going to be, looks like each of these tick marks is 1, so 1, 2, so it's 1, 2 by 1, 2, 3. So this is a 6, area of 6, and it's below the x-axis, so it's going to be a negative 6. All right, so what is this function? It is evaluated between 2 and 4. So between 2 and 4, and the function was negative 3 dx. This spot right here, I should have said it was negative 3. So doing this analytically, we see that this is going to become negative 3. Our variable is still x. And that's going to be evaluated with the evaluation bar between 2 and 4. So now subbing in, we get 4 times negative 3 is a negative 12. I'm going to put parentheses around these so I don't get messed up here. Subtract, subbing in 2. 2 times negative 3 is a negative 6. So this is going to be a negative 12 plus 6. And so I have a negative 12 plus 6. And that is negative 6. Perfect. So we're getting the same answers. And I guess I should be, as always, boxing our final answers. Box final answers. And making sure they match, of course. All right, let's check number 3. So draw a line to the x-axis. Okay, well, I could have drawn that a little bit better. Let's try that. All right. And this is the area that I'm trying to find. Anything under the line. All right. And I'm evaluating between 0 and 4 for this triangle. And I prefer making everything into a rectangle. And you probably won't make that mistake. I'm just saying make it into a rectangle so that we can't make the error of messing up the triangle formula. So if this is our rectangle, it's going to be a 4 by 4 rectangle, so it has an area of 16, and then half of that area is going to be 8. So I should do it in red so it sticks out more. All right, so now coming down here to the analytic version of the evaluation, we have the integral between, this is always the x coordinates, x equals 0 to x equals 4. 0 to 4, and what is our function? It's no longer a constant, it's no longer just a straight flat line. It is a linear function, a line that has slope. And the slope of that line, it goes up 1, or sorry, right 1, up 1, so it has a slope of 1. So 1x, or just x. And then the y-intercept is 0, so x plus 0, and then dx. Perfect, now I'm going to integrate, and that's going to be, I'll actually give myself some room here because I'm going to have x squared, goes up a power, and then I divide down, so it's going to be 1/2 x squared, evaluated between 0 and 4. And that is going to turn into, hold on, give me a sec. Sorry about that. That's going to turn into, I sub in the 4 first. 4 squared is 16. Half of that is going to be 8. And that's going to subtract, subbing in 0. That's going to be 0 squared is 0 times a half is still 0. And I get 8. Perfect. They match. All right, moving on. Number 4. We're finding this area. Well, I can try to do this a little bit better. This area right here. All right, so I'm between 0 and 1, and if I make my rectangle so I just don't mess up, and this is going to be height of 6 by 1. 6 times 1 is 6. Half of that is going to be 3, so we can label that triangle 3. Perfect. And let's go ahead and find, oh, this is f prime. Does that affect anything? Let's read the instructions. There are no instructions. That's probably why we're all confused. But I think that's what I'm looking for. Just asking for 3 for the area of that triangle. All right, so this is going to be the integral. Oh yeah, so that makes sense. The integral from 0 to 1. So from 0 to 1. And what is the equation? This guy is maybe a little bit hard, but it goes right 1, down 6. So if you always if you ever struggle with slope, just remember that slope is equal to the change in y divided by the change in x. And in our case, that is going to be the change in y. It goes down 6, so it's going to go down 6. And the change in x goes right 1. So the slope is equal to -6. And so our equation is -6x. And then the y-intercept is plus 6. And be careful here because you don't just write your dx right here. If I were to do this dx, that would be incorrect because I'm only multiplying the 6 times the dx. I need to make sure that all of this is multiplied by the dx. Now it's correct. All right, so solving this analytically. How do I do this? I'm going to go ahead and integrate. So I'm going to integrate individually. It's kind of like the distributive property of this integral applying to the -6x and this integral applying to the 6. So first, this integral applying to the -6x, and I get it's going to be a -6x. I go up power, so squared, and then divide down, divide by 2. And that's going to be evaluated from, actually, you can do the entire evaluation. You can do the evaluation here from 0 to 1, and then add it to the next one, or you can just do it all at once. I'm going to do it all at once. So that's the first part, and I'm going to say plus 6x, because the integral of 6 is 6x, and all of this, everything in here is evaluated between 0 and 1. All right, what is this going to turn into? If I plug in 1, I have a 1 squared is 1 times, this is -3. 1 times -3 is -3. So maybe I should write that up here so I don't forget. I had a -3, and then 1 times 6 is 6. So a -3 plus a 6 is a 3. So change back to my color. That turns into a 3. Plug in 0, that's a 0. Everything there is 0. Everything there is 0. That's -0. And the final answer is 3. Perfect. And they do match up. All right, moving on. So this guy, always draw a line directly to the x-axis. First step. Next step, go ahead and shade in the area that you're looking for. We're looking for all of this. That's a little bit hard to do because it's a weird shape. Make the shapes easier. Let's do that by doing a line like that. And now I have a rectangle and a triangle. Let's go ahead and make that triangle into a trapezoid, or not a trapezoid, a rectangle. All right, let's find the area of this rectangle down here. So that's going to be 1, 2 by 1. So that's just an area of 2. And this rectangle here is a 1, 2, 3, 4 by 1, 2. 4 times 2 is 8. Half of that is 4. So the total area here is 6. All right, let's see if we can do the integration over here. So it's evaluated between, changing color, between 0, x equals 0, and x equals 2. So 0 to 2 of, now I need to find the equation of this linear, of this line. So let's take a look at what's happening. So it goes right 2, up 1, 2, 3, 4. So it has a rise of 4 and a run of 2, which means it has a slope of 2. I'm just kind of using this generally speaking. So this is going to be a 2x. Y-intercept is 1, so plus 1. All of that times dx. All right, so I have my equation. Let's go ahead and integrate, very similar to the last problem where I do each of them individually. 2x squared is going to become an x squared because the 2 gets divided down. And then this is going to be plus x. Evaluation bar between 0 and 2. This will turn into, subbing in 2, that's going to be 4 plus 2 is 6. Subbing in 0, and I get 0. So my final answer here is 6. And they do match up. Good. Analytic matches graphical. Okay, next one. So draw a line to the x-axis. Draw a line to the x-axis. Shade in the area that we're looking for. We are looking for that area, so let's go ahead and make it into basic shapes. So this is a rectangle down here. That's a triangle, but I'm going to make the triangle into a rectangle so we can't make a mistake. Rectangle on the bottom, that's a 1, 2 by 1, so that's an area of 2. This rectangle is a 1, 2 by 1, 2, 4. Half of that is 2. This entire area should be 4, just adding up the areas. Notice that so far in all of our problems, they've all been, aside from this one, they've all been above the x-axis, so I'm not worrying about the negative or positiveness of this graph. So now checking my work, switching color to blue, we have between 2 and 4, between the x-coordinates of 2 and 4, 2 and 4, and what is our equation? Our equation, and it doesn't matter if the where the line starts and begins in terms of like starting here versus starting here, we just need to make sure that the equation is true. So if we were to continue that line, and I can use technology here to help us out, if I were to continue this line, where would that hit the y-axis is more of the question, because I need that y-intercept. And you can see that it will intercept at -1. And there's a way to do that algebraically, but I'm not going to go through that right now. You can ask me in a text or email, whatever. So coming back here, what is our equation? We know that we go right 1, up 1, so we have a slope of 1, so it's just x. And then our y-intercept is -1, so x minus 1, and dx. So let's take the integral. So when I integrate this, x squared, it's going to be x squared, divide down, so it's 1/2 x squared, minus, and this is going to be an x. All of that is evaluated between 2 and 4. 2 and 4. Subbing in, here we go. 4 squared is 16, half of 16 is 8. And I need to write that above here because otherwise I'm going to forget. We got an 8. And then minus 4. 8 minus 4 is 4. 4. Minus, subbing in 2. 2 squared is 4. Half of that is 2. I can write that in a different color. That's going to be 2. And then 2 minus 2 is 0. So you can write 4 minus 0. And again, we get the same answer that we got in our graph. We're checking our work this way. Perfect. On to number 7. All right, so starting to get harder and harder. I need to find the area of this function between 2 and 4. So here we go, drawing a line to the x-axis. Okay, shade in the area that we're looking for. Some people might confuse it, like maybe we're looking for that area or something. I'm not sure, but we're looking for this area there and this area there. We're adding them up. So I'm going to go ahead and make these into rectangles, and that's going to look like this. So the area of this rectangle on the left is a 1 by 2, so it has an area of 2. Half of that is going to be 1. This rectangle is a 1 by 2 as well. Half that is going to be 1. So the answer here is 2. All right, and here's a graph of f. I'm evaluating between -1 and 9. So -1 looks like that. Oh, I should switch to blue. -1 is right there, and 9, I don't have to draw anything. All right, shade in the areas that we're looking for. We're looking for this area here, and we're looking for this area here. Okay, so let's divide this into easier shapes. So I'm going to go right here, and I'll make a line there. And then, of course, I need to make everything into rectangles so I don't make any mistakes. All right, so this rectangle on the bottom, it is a 1, 2, 3 by 1, so it has an area of 3, but it is below the x-axis, so it's going to be a -3. This triangle here is a 1 by 1, so it has an area of 1. Half that is half, so I'm just going to say 0.5, and it's below, so a -0.5. All right, up here we have a rectangle of 2 by 2. That's 4. Half of that is 2, positive, because it's above the x-axis. This rectangle up here is 1, 2, 3, 4 by 2. That's 8. Half of that is going to be 4. Adding all these up, this is going to be, I'll say with negative 3 plus negative 0.5 plus 2 plus 4. So it's 6 minus 3 is 3 minus a half is 2.5. So this is equal to 2.5. And I should be boxing my answers. 2.5. All right, so now we're going from negative 2 to 2. So negative 2 is right here. 2 is there. Okay, shading the areas that we're looking for. We're looking for this area here. We're looking for this area here. All right, divide it into easier shapes. So I have a triangle, making it into a rectangle. I have 2 triangles here, make them into 2 rectangles here. All right, so this rectangle is a 1 by 1, so it has an area of 1. This triangle, well, it's really the rectangle here, is also 1 by 1. It's the same exact shape, but half of that, so this is going to be half, 0.5. Rectangle down here is it's a 1 by 1, so it's a negative 1, but it's half of that, so it's a negative 0.5. This rectangle is the same thing, negative 0.5. So this is going to equal 1 plus a half plus negative a half plus negative a half. Simplifying this a little bit, this is going to be 1.5 minus 1, which is equal to 0.5. And moving on, we have our last set of problems. So I'm trying to find the area between negative 6 and 6. So negative 1, 2, 3, 4, 5, 6. So from right, I should change color here to blue. So from right here to right here. All right, so shade in the area that we're looking for that area right here. All right, again, we have triangles, so I can just make this whole triangle into one giant rectangle if I wanted to. So this entire rectangle is a 6 by 3, 18, and it's a triangle. Half of 18 is 9. Again, same thing with this triangle. It's going to be, it's the same shape, right? It's still 9, so this is going to be 18. It's going to be 9 plus 9. I don't know what the equals is down here. 9 plus 9, 9, and we get 18. Terminato. Okay. Moving on, we have integral from negative 3 to 2, negative 1, 2, 3. So right here to 2, so right here. Always draw to the x-axis. Okay, shade in the area that we're looking for. We're looking for that area here and that area there. All right, so let's divide this into smaller shapes. So I'm going to have a lot of different shapes here. Yeah, everything here looks good, and we'll go ahead and make rectangles out of some of these shapes. Rectangles. All right, so this first triangle up here, that is going to be a 1 by 1 rectangle, so this is going to have an area of 1/2. I should just do 0.5, it'll fit better. 0.5. This rectangle is 1 by 1, so it has an area of 1. This rectangle is a 2 by 1, so it has an area of 2. This rectangle here is a 2 by 1, so it has an area of 2. Half of that is 1. This rectangle is a 1 by 2, so it has an area of 2. Half of that is 1. This rectangle is also a 2 by 1, and half of that is going to be 1, but it's on the negative side. It's a negative. It's below the x-axis. All right, let's see what we got. We got a half. We got a 1. We have a 2. We have another 1. We have another 1. And we have a -1. All right, so adding these all up, let's do some mental math. So 1 plus 2 plus 1 plus 1, that's going to be 5. -1 is 4. Plus a half, that's going to be 4.5. Hopefully I'm doing this correct, even though I'm going fast. Of course, if you catch mistakes, text me, you get the extra credit. All right, so what do we have here? Oh, we've seen this graph so many times on the test. It looks familiar to me. Let's go ahead and find the values from -2, so from here to 3 to here. Okay, what values, or what area are we looking for? We're looking for that area, we're looking for this area, and we're looking for this area. Okay, so let's go ahead and make rectangles. Rectangles. Okay, that was a poor rectangle. Let's try that again. rectangle. Ooh, this one's going to be hard, but this one kind of looks like a circle if I were to complete it. And this is also, oh, come on, Mr. Sindel, a rectangle. All right, so this rectangle is a 1 by 1, so half of that is going to be half, so I'm just going to say 0.5 right there. And this circle, area of a circle again, area of a circle is equal to, whoa, what's going on with my pen, is equal to pi r squared. You should have that memorized. The radius here, the radius you can see going up is a radius of 1, so radius squared is 1 squared, which is 1, times pi. So this whole circle has an area of pi, but we want half of that. So this half of the circle is pi over 2. I'm going to write that down here. Pi over 2. Don't know what happened there. Pi over 2. And that's referring, of course, to this area. And finally, this is going to be a 2 by 1. 2 times 1 is 2. Half of that is 1. All right, what do we got? We got 0.5 plus pi over 2 plus 1. So the answer here is 1.5 plus, here we go, pi over 2. Done. All right, hopefully that video helped. I'll see you guys for the next lesson.